Let's talk about sigma notation. So sigma is the letter you see here. This is the Greek letter that is equivalent to our capital S, and it means like it's S for summation. So in math, we use this sigma when we're trying to add up a very long list of numbers that have some sort of pattern in them. I'm going to show a few examples in this video so you can get the hang of how this notation is used. All right, so in this first example, we have kind of a standard sigma notation setup. So there's always to the right of the sigma some sort of formula with a letter in it. Below the sigma, it'll have letter equals a number, and then there'll be another number at the top. So you can see in my second example, similar situation, there's a formula on the right side, k equals 2 down below, and then another number up above here. Okay, so in my examples here, I'm going to use K, and then you can see my third example uses an I as the letter. Typically, I, J, K are the letters that we use for sigma notation. We tend to avoid X only because the letters in this case will stand for integers. And X usually implies that it's like a continuous, you can plug in any decimal number. Okay, so what this notation in this first example means is we take whatever number is at the very bottom here. So in this case, k equals 1, and we're going to plug it into this formula. So if I plug 1 in for k here, I get 1 squared. And then this has addition between the terms. So we add, and then we're going to count up by 1, right? Because this is always an integer. So we plug in the next number, that's 2 squared in the formula. And then the next number, that's 3 squared. And then I stop at this term because of the 3 that's at the top of the sigma. So what these numbers at the top and bottom are telling me are the first k value to plug in, and then the last k value to plug in. So it's always lowest number here, highest number here, and it's integers in between. All right, so this is only 3 terms, but it's kind of giving us the hang of things here. We can actually compute this sum. This is 1 plus 4 plus 9, which is going to give me 14 for a final answer. So this sum is equal to 14. Let's try the next one. So this is the sum of 1 over k as k goes from 2 to 6. So I'm going to take the 1 over k formula and plug in this first number, k equals 2. So that gives me 1/2. Addition between the terms, I'll go to 1/3, then a 4th, then a 5th, then a 6th, and I stop at 1 over 6 because 6 is the upper number here. This sum, I'm not going to bother computing out the exact total. This is kind of giving us a sense of how these sums are going to be for us in the future, where they lay out something that's a lot more complicated when you expand it out, but then it wraps it up into this very neat little package. Okay, so let's try one more of this type. Here I'm using the letter I instead of K, but it works the same way. So my formula is I over I plus 1. We're going to start at I equals 0 and go up to 3. Notice it's kind of bizarre to be using I as a variable here, but it does not mean like the complex number I. We just mean it as like a stand-in variable here, just like the K. So if I plug in 0 first, then I plug in 1, then I plug in 2, then 3, in for I in the formula. And again, I stop at the term with k equals 3 in it, or sorry, I equals 3 in it, because 3 is the top number up here. So that tells me this is the last term. So on my way to computing, this would be 0 plus 1/2 plus 2/3 plus 3/4. And again, I'm going to leave it here. We're more concerned with what the summation symbol meant more than the actual computation number. All right, so my last example in this video is just of doing this kind of backwards. So instead of being given the sigma notation and asked to write out the sum that it represents, we might start with a sum that has a pattern and turn it into sigma notation. So I encourage you to pause the video and give this a try yourself. Come up with a sigma notation. There's more than one correct answer that would represent this sum here. All right, so one thing you might do I'm going to set up the sigma symbol. We might start by just deciding what the formula will be. And because each of these are square root of consecutive numbers, you might say square root of k or square root of I as your formula. And then we say, all right, this is square root of k with 3 plugged in, and then we go all the way up in order until 7. So I'll say k equals 3 and then put a 7 on top. We could also do this with another letter, right? I could use square root of I equals 3 to 7. These mean the exact same sum. Or you can get even more creative about it. We could also, if we really wanted k to start at 1, because that's nice and organized, we could make our formula k plus 2. Right? Because then when you plug in k equals 1, we get square root of 3, and then 4, and then 5. And then we would have to go up to k equals 5 in this case, so that we would end on square root of 7. So there's some flexibility with sigma notation. All these are correct answers, and there's a whole bunch more out there that we could brainstorm.